We are going to go through one of the most crucial, vital instruments in modern forensic toxicology. This is that of the mass spectrometer. A mass spectrometer is an instrument with a relatively simple concept. It is able to ionize a sample and measure the resulting mass to charge ratio, with the ability to then distinguish between chemical components and elements. Now, to allow for an increased specificity of the mass spectrometer, it is commonly coupled with a chromatograph, and this can be seen in labs globally. However, which chromatographs are they coupled with? The most frequently used are that of two types. The first is GC, or gas chromatography, and the second one is liquid chromatography. Now, both methods are similar in certain instances. For example, they both require a mobile and a stationary phase during their processes. However, they are still both different. For example, LCMS requires a solvent, whereas GCMS uses an inert gas such as that of helium for its mobile phase. So firstly, let's talk gas chromatography. This is a popular analytical technique that separates volatile compounds from their mixtures, and this is arguably the most common combination in modern forensic science. As a result, GCMS, gas chromatography mass spectrometry, and is known to have quite literally revolutionized the analysis of compounds in complex matrices. Most commonly seen to analyze things such as benzene, alcohols, steroids, fatty acids, and hormones. Now, put simply, the process of GCMS can be broken down into three main steps. The mixture of chemicals are separated, identified, and quantified. For the compound to be analyzed, it must be sufficiently volatile and thermally stable. Great, but what's the catch? Because nothing is that simple. There are some noteworthy disadvantages to using the GCMS instruments. For example, compared to alternative options, the analysis time of this method is considerably slower, with an average time of 30 minutes, whereas other instrumentation is known to analyze at speeds of 1 to 5 minutes. Although that is a major disadvantage, the upside is the higher specificity in comparisons to its counterparts such as that as LCMS. Slow and steady wins the race, I guess. So what about its counterpart, liquid chromatography mass spectrometry? Similar to GC, liquid chromatography will separate the sample components and introduce them into the mass spectrometer. This instrument is known to be important in several areas of science, such as that as clinical biochemistry, and is known to compete with conventional techniques such as that as immunoassay. This at times may be chosen over GCMS as it's known to analyze compounds that it can't. For example, if they're not thermally stable or non-volatile. However, just like before, there are also disadvantages to this technique. Although there is a significantly faster analysis time and a reduced sample preparation, LCMS is known to have a very high operational cost. Overall, although both methods are relatively similar, in the sense that they separate the chemicals via chromatography and then further examine and identify them through a mass spectrometer, GCMS is for now the preferred standard for forensic identification.